Hi everyone, welcome to Refrigerate Right. Does your ammonia refrigeration system comply with chemical accident prevention requirements? My name is Elise Simons and I am an assistance provider with EPA Region 1 in New England. And joining us for today's webinar will be Len Wallace, who is a New England Regional Inspector, and Catherine Smith, an attorney in Region 1. So in today's webinar, we're going to discuss some key safety measures and some common unsafe conditions and best practices for ammonia refrigeration facilities. Sorry, hold on one moment. We're also going to talk about ways of pilot projects for EPA to promote compliance with the General Duty Clause of the Clean Air Act and other laws and regulations that may affect ammonia refrigeration facilities. We're going to hear from Len about some inspections and common issues found at facilities. And at the end, I will be talking about some additional resources that you can access for more information about ammonia refrigeration and these laws and regulations and best practices. So just as a quick note, the presentation that you're seeing today is also available for download from the resources folder that's on your screen, and we'll be sending it to you after the webinar. So don't worry about writing down any of the websites you see on your screen today. All that will be provided to you at the end. So just before we get any further, a little bit about webinar logistics. I hope everyone's able to hear me, but if you're having any difficulty, you can try switching your audio option. You can either dial in by phone or through your computer, and if one is giving you trouble, switching to the others may help you. There may be a slight delay depending on your internet connection, so we do ask you to bear with us if your slides are loading slowly. All of you are attended throughout the webinar, but if you have any questions, don't worry. You can type your questions in the question box on your screen at any time throughout the webinar in the questions box. We'll have a question and answer session at the end of the webinar. So any questions we don't get to during that question and answer session that you've typed in the box, we will respond to via email after the webinar is over. There's also going to be a short survey that will pop up at the end of the webinar, so if you're able to fill that out, we appreciate your feedback. Now, please take a moment to read this disclaimer. Great, thank you. So, why are we here and what are we talking about today? Well, in 2016, EPA launched a national compliance initiative that's focused on reaching industrial and chemical facilities through outreach and education and enforcement action. The goal of this initiative is to reduce the risk to human health and the environment by helping to prevent chemical accidents and also increase compliance with regulations and to promote communication between facilities and emergency responders. So ammonia refrigeration has been chosen as a top priority under this initiative. There's more information at the link on this slide. Ammonia refrigeration was chosen as a top priority because while it's a very efficient and cost-effective refrigerant, and while it does not deplete the ozone layer, unlike some refrigerants, ammonia, it does have some dangerous properties and it does need to be handled with care. Ammonia is toxic, it's highly corrosive, it is flammable at certain concentrations in the air, and inhaling ammonia fumes can be fatal. Anhydrous ammonia releases at facilities have resulted in property damage, injuries, and even death. EPA has responded to these incidents with enforcement actions and imposed over $10 million in civil penalties since 2012. So a safe ammonia refrigeration facility will have many layers of different protections to prevent releases of ammonia and to manage the effects of any releases that do occur. A facility needs to be designed with safety in mind. Employees also need to be trained in safe practices. There should be an automated detectors and emergency shutdown systems in case of a release. And finally, it's important to establish emergency response procedures with your local responders well in advance so you're prepared just in case a release does occur. All these layers of preparation and protection all work together, and every single one is crucial to preventing and minimizing damage from any accidental release. Before we go any further, I just want to take a quick poll. We're asking, what sort of ammonia refrigeration facility are you? So if you are not an ammonia refrigeration facility, you can choose other. We also have dairy or cheese or ice cream facilities, food processing, cold storage and distribution, and ice rinks. We'll give you all a minute to fill that out. Okay, great. So let's take a look at our results and see who's joining us for this webinar today. We've got 28% of you are ice rinks, 21% food processing, 9% dairy, 18% cold storage, and 25% other types of facilities or not facilities. Thank you for that. Now I'm going to turn things over to Len Wallace, an inspector in EPA. Take it away.
Good morning, everybody. I'm going to be talking a little bit about the Clean Air Act 112R, which is divided into two major components regarding ammonia. One is the general duty clause, and the other is risk management programs. And what is the difference? Risk management program is for any facility who has 10,000 pounds or more of anhydrous ammonia or aqueous ammonia at their facility. They're going to be under a regulatory program. General duty, on the other hand, has no regulations, and it's performance-based standard with three major requirements. Catherine Smith is going to go into much more detail into these two requirements. But one of the many things that you have to understand, it doesn't matter if it's general duty or risk management, is understanding your industrial standards of care for your type of facility. Some of the common anhydrous ammonia industrial standards of care for prevention mitigation, so many of you should recognize these, is IIAR, the International Institute for Ammonia Refrigeration, ASRI, the American Society of Heating, Refrigeration, and Air Conditioning, and ANSI, the American National Standard Institute. Along with these, also you have to be aware of state and local fire codes as well. From the key safety measurements documents, a couple of the things that you really should be aware of. The key safety measurement document was developed by the EPA with input from the IIAR. Some of these key things are easily verifiable. They are not all the safety standards. They are just simply standards that can be verified very quickly in the field and visually many times. Identifying hazards is probably one of the key components, is identifying what you have at your facility. How does your facility operate? How is it designed? And one of the best ways to do that is to do a process hazard analysis. This is key. Without a process hazard analysis, you don't know what needs to be fixed, what time frames, and many times you need an expert. And there are a couple different types of experts you can use here. One is someone who actually specializes in process hazard analysis. Another type of expert could be a person who knows how to run an ammonia system. And the third is actually engineers who would help with doing engineering diagrams and how the system is laid out for a process instrumentation diagram. Having information available about your system to identify the hazards is extremely important. A lot of people think of just block flow process diagrams, but within that is also your process and instrumentation diagrams, which get into very engineering detailed as the type of piping, the schedule, the length, the size of your tanks, all your valves, where the valves are located, SDS sheets, safety data sheets for your anhydrous ammonia, your oils. If you have glycol or other medias that are used to transmit the cold to other places in your facility. Equipment lists, such as the maximum pressures, the capacities of your compressors or your tanks or your pipes. Operation ranges. There's a minimum range, there's a maximum range. Where do you fall in to accomplish your goal at your facility? How much ammonia do you need in your system? Many systems don't operate at maximum capacity, and if they do, then usually it's almost time for an expansion because you're pushing your equipment. And it's the reverse. If you lose ammonia, then you're also stressing the system. Desired operation ranges is really critical for an efficient system. Ventilation systems. Not only is it the capacity of the system, but is it being ventilated properly? Are you bringing fresh air in the correct areas, and are you exhausting it out? So it's not just about, oh, do I have a motor that can push the required air out of the room for the air exchanges, but it's also how it's set up. And again, knowing different industrial standards, and many of the manufacturers have recommended schedules. And if you're not going to follow those schedules, what other standards are you going to use to replace the manufacturer's recommendations for scheduling? Another key provision is to prevent accidents is your standard operating procedures at your facility. Having written procedures is critical for especially maintenance procedures. Knowing who's authorized, who's trained to do those activities, who's trained and authorized to go into those different parts of the facility. Are you going to do it yourself? Are you going to have your contractor do it? And making sure everyone is aware of what needs to be done and when. One of the major areas where releases occur is actually one of the simplest jobs, but it's actually very complicated in making sure that it's done properly, is just taking oil out of your oil pots. It sounds simple, but almost 80% of the accidents we've seen in New England start with changing or trying to remove oil because the people either didn't follow their procedures or they didn't have any procedures. And one of the key elements is having a quick close valve on the oil. Otherwise, if you don't, just imagine turning one of these handles and then having oil and ammonia gases spraying at you. You're not going to be able to reset those very easily. And having a self-closing valve on your oil pots is critical for safety. Another key safety is maintenance and mechanical integrity. Prevention programs, maintenance, following the schedules that your manufacturer of the items, such as the tanks, the valves, the pipes, all have scheduled maintenance. There's visual, and sometimes then you have to have other types of testing done, ultrasonic testing, x-rays to determine, but controlling corrosion. Corrosion for ammonia systems, unless you're stainless steel, is a critical element of your maintenance program. Wiping off, dusting off that light rust and keeping the system painted is critical. Keeping your vapor barriers critical. Ice buildup, especially on pipes and evaporators, is critical because too much weight can pull them down. Hammering, pipe hammering. That's where a pipe dead ends, and are you keeping the surge of the materials from making sounds inside your pipes or keeping them from vibrating when that occurs? Again, I'm going to cover corrosion. Corrosion is one of the more common elements that we see throughout systems. And the bigger the system, a lot of times the harder it is to keep up with it. But it's also where a lot of accidents occur because of different corrosion. And if the corrosion is great enough, then not only it's no longer just painting, it's actually replacing a piece of equipment or the piping of the valves when it gets too far along. Breaching vapor barriers. The reason you have vapor barriers is to keep the cold in, the moisture out, and when these barriers are breached, and many times it's simple as forklifts or people doing things next, and it allows the moisture in, and then all of a sudden you have moisture on the tanks or the pipes, causing accelerated rusting. And in many cases, similar to this, is where the ice actually has forced the insulation away from the vessel. Speaking of ice buildup, we have a refrigeration facility that was on auto for over 3 years, no one paying attention, and the cold should be on the other side of this wall, yet almost 2.5 feet of ice is in the emergency stairwell, along with other electrical issues that shouldn't be on an emergency stairwell. Building up of ice on emergency valves, and yes, there are emergency valves between the red door and the bluish-greenish door, where that ice, you can see about 3 feet off the ground. Those are emergency valves that no one now can get to because of the ice buildup on them. Along with normal maintenance is having all your plugs and caps, different things locked. You need to have your valves labeled. You need to have your pipes, your tanks labeled, so that they can be easily understood by you, your contractors, and if there is a release, especially the emergency responders who may not be as familiar with your community. And many times, hazmat teams and other agencies come from long distances, and it may not just be your locals that are helping you out. Another issue is replacing valves. Many of the safety valves have to be replaced every 5 years, and that is a lot of times overlooked. Appropriate labeling. The labeling standards have changed over the years, but again, many facilities, one of the simplest things is labeling. A lot of times you get painted over. There are different ways to attach labels other than just putting them directly on the pipe. You could use sleeves and other types of devices, which then can be taken off and put on very easily. Identifying your tanks. When a tank plate rusts or falls off, we no longer know who manufactured this, what's the use stamp. It's very hard unless you have the paperwork. In many cases, when equipment is 30 years old or 20 years old, and you're not the original folks who ran this facility or built it, a lot of times there's a lot of work, or you have to end up doing testing or replacing this type of equipment. And by the way, you can put a new plate on, and it will say replacement on it. Some of the other things for ammonia machinery rooms is not only its design, but it's designed to isolate ammonia in that room and keep it in that room. So rooms that are not isolated, they're not functioning as they should be. Along with the ventilation system is to vent that room. And you may have more than one machinery room at your facility. That's critical to understand, especially for larger facilities. They may have multiple machinery rooms because of where they have tanks and other equipment. So you have to have how it's going to be vented, how it's going to be tested, the positioning of the air inlets and where it's going to be exhausted, how your relief valves are adequately sized so that ammonia doesn't build up and pressurize in those systems. An example of someone not quite understanding ammonia. Here we have an ammonia tank inside a shed. It's not vented to the outside. The relief valves vent directly into the building. And by the way, these relief valves were over 20 years old. so they didn't meet the 5-year replacement either. Ventilation. We talked about having fresh air come in. We had exhausted upward towards the sky. So a hole in the floor to allow fresh air in with a fan at a door opening is not what we call adequate ventilation in an ammonia machinery room. And this is actually how a facility with over 5,000 pounds of anhydrous ammonia thought they had adequate ventilation here in New England. Emergency actions. One of the critical parts is, yes, your employees or your contractor may be able to hit the emergency buttons as they go out, or your detectors will detect the ammonia once it either gets to like 25 parts per million or 100 and activates different parts of the machinery automatically. But at some point, the responders are going to show up, and you have to have clearly marked schematics of where the critical shutoff valves are for them to understand your system, along with the procedures depending on what side of the system, whether it's the gas high pressure or the gas low pressure, what valves that you want them to isolate the system. It's critical that the Tier 2 form from EPA, Emergency Planning Community Right to Know, is filed by March 1st of every year to your local fire department, your local emergency planning committee, and your state emergency response commission. And note that some states have additional requirements and have lowered thresholds for materials. Talking about shutoff valves, they're supposed to be so that any person running out of a building, evacuating a building, or coming towards the building to use those shutoff valves, that they be accessible. Not trying to figure out how to get 20 feet up a wall to use a shutoff valve is not in their criteria. Some other features. These are both things that should be at a facility and things that we're going to show you that are missing or not correct at the facility. So having a door properly marked, having a tight fitting door to keep the ammonia on the inside, having an emergency shower just outside the door are critical features. Ammonia detectors and alarms and push buttons, they have to be clearly identified to what their functions are. Without that, both the responders, your own workers, and your contractors may not know what these devices are for or what they're going to do. Here's an example of what shouldn't have been happening. Just above the caution sign, that's an electrical panel, is a pipe in which the insulation was destroyed somehow. The pipe is carrying a liquid at 20 below zero, and the room's at 100, so we have a little ice and constant melting. And what looks like glue on the panel is not glue, that is water going down and through the panel, and there's actually a puddle on the floor. So you wouldn't want to make contact. It'd be a shocking experience. Another example of housekeeping. On the left, we have water and oil going down a drain to unknown. We have electrical wires. Again, as you can see, nothing is labeled. And on the right-hand side, you're not supposed to have flammables or combustibles in a room that's not sprinkled. And yet we have cardboard and oil, and we actually have a car. There were actually gas cans and other materials in this room, which should not have been in this ammonia machinery room. So again, just paying attention to housekeeping is one of the critical elements in an ammonia machinery room. Accessibility to emergency shutoffs are in the business king valves, and you can have more than one king valve. A lot of people think you only have one, but you can have them. But when we say accessible, that means a person, an average person, can reach it and turn it. And if they can't, you either have to build a platform or have it on a key with a chain so that they can operate it. And it has to be clearly identified. Here we have an accessible king valve, but the valves aren't properly identified. So we had the one before that were way above someone's head identified, but they weren't accessible. Here they're accessible, but they're not identified.
Great, thanks, Len. Before we move on and hear from Catherine about some regulations, I have another poll for all of you. This next question is, how much ammonia does your facility have on site? And again, if you're in a facility, there's an option there for you as well. Okay, great. Thank you all for your responses. Let's take a look at what we got. We've got 50% of those attending have less than 10,000 pounds of ammonia at their facility, and 31% have over 10,000 pounds, and then 19% don't have ammonia and are not a facility. So thank you for that. Next, we'll hear from Catherine Smith.
Hi, everyone. I'm Catherine Smith. I'm an attorney in EPA Region 1, New England, and I have been working on chemical accident prevention for longer than I care to admit. What I'm going to do first is give you a very brief overview of some of the federal laws and regulations that would apply to ammonia refrigeration systems, and then go into more depth on the Clean Air Act laws and regulations that apply. So due to the need to handle anhydrous ammonia with great care, several federal and state laws may apply to the design, installation, and operation of your ammonia refrigeration system. These laws include two commonly enforced by Environmental Protection Agency, Section 112R of the Clean Air Act, as well as the Emergency Planning and Community Right to Know Act, which Len mentioned. And my presentation today will focus mostly on the Clean Air Act requirements. In addition, to protect workers, OSHA enforces regulations that look very much like very similar to EPA's Clean Air Act 112R requirements. OSHA and EPA both are focused primarily on preventing and responding to accidental releases, whereas the Department of Homeland Security is tasked with preventing sabotage and terrorist acts. They enforce the Chemical Facility Anti-Terrorism Standards, or CFAT. In addition, states have fire, building, and mechanical codes that often have provisions about ammonia refrigeration systems. You should know that all of these agencies often work together and coordinate. We get tips and complaints from our partners. We sometimes inspect with these partners, and there's a very strong network in New England of state, local, and federal regulators. Finally, what you need to know is that for EPA's laws and regulations, Clean Air Act 112R in New England is not delegated to any state, so that's EPA enforcing them. We'll go back to the slide that Len showed you earlier. There are two enforceable prongs to Clean Air Act Section 112R, the General Duty Clause, and then what we colloquially would call the Risk Management Planning Requirement. Their real name are the Chemical Accident Prevention Provisions. They're found at 40 CFR Part 68. Now, Clean Air Act 112R was added to the Clean Air Act in 1990 after some horrible accidents occurred both abroad and in the United States. looking at the left-hand column and comparing the general duty clause and the risk management planning requirements, general duty clause applies to stationary or fixed sources that manage extremely hazardous substances. One of those substances that Congress explicitly set out in the law is anhydrous ammonia. Now, if you're a stationary fixed source that manages extremely hazardous substances, including anhydrous ammonia, you have to do three things under the general duty clause. You have to identify hazards that might result from the release of ammonia using appropriate hazard assessment techniques. And that can include, for example, using industry checklists or using a what-if technique. Those are the two most common for ammonia refrigeration. So that's the first duty. The second duty is to prevent releases by designing and maintaining a safe facility. Now, that's not as vague as it looks. What we do is we look at the industry standards of care, and those are the industry standards of care that Len just talked about. And so these are all the industry standards of care that are out there and very clearly laid out to help facilities design and maintain a safe facility to prevent releases. Lastly, the third duty requires you to minimize consequences of releases that do occur, and that includes things like emergency planning. Now, if you have over 10,000 pounds of ammonia in your refrigeration system, you're subject to the risk management planning rule. And that again applies to stationary fixed sources with listed chemicals, including anhydrous ammonia, over 10,000 pounds in a process. It is entirely possible at some ammonia refrigeration facilities that you would have two refrigeration systems, one with over 10,000 pounds, which would be subject to the RMP rule, one with under 10,000 pounds, which would be subject to the general duty clause. If you are subject to the RMP rule, you have to submit an RMP plan to EPA and follow detailed regulations, RMP regulations that essentially just flesh out those general duties you see on the left. There are 3 program levels in the RMP regulations, depending on risk. Most ammonia refrigeration facilities that are subject to the RMP rules are in Program 3, which is the most detailed. Essentially, you have that are required of facilities at all programs more things, and the basic requirements are to analyze the worst case release zone. That's to determine which responders would be involved and what neighborhoods would be affected by a worst case release. You have to complete a 5-year accident history. You have to coordinate response actions with local emergency response agencies, and at least every 5 years, you have to submit to EPA a risk management plan. Facilities with Program 2 and 3 processes have to take some additional steps. There's some more comprehensive emergency response program requirements, and you have to have a detailed release prevention program. And I like to think about this release prevention program as sort of falling into 3 different categories. The first in blue are the steps that you take to actually understand the hazards of your system. So compiling the process safety information, as Len discussed, and then conducting your process hazard review or analysis. The second set of things in green are the steps that you take to make sure that your facility is operating safely, complying with industry standards of care, using safe operating procedures, training employees, and maintaining your equipment. And then taking steps in purple to make sure that your risk management program is operating well, which includes conducting compliance audits periodically and investigating any incidents that do occur so that you can learn from them. For Program 3 facilities, there are some additional requirements such as managing changes to your facilities, making sure that employees and contractors understand safety requirements. And an issue that we see with some regularity is failure to get hot work permits for hot work done around ammonia. Turning to enforcement, what we like to do is prevent accidents. So we prefer to conduct inspections at facilities before any accident has occurred, and then work with the facility to get in compliance and prevent an accident. But regrettably, due to the number of ammonia releases that occur, we are often in the position of inspecting after a major release has occurred. Our cases tend to be pretty complex because we're not just looking at the Clean Air Act when we go out to your facility, we're also looking at your compliance with the Emergency Planning and Community Right to Know Act and release reporting requirements. Our cases can be multi-statute. Sometimes if we go to a facility and it's particularly scary looking, we call in an expert to help us better understand how that system is working and what's needed to make it safe. So often we're calling in an expert. And then, as I mentioned earlier, we do work with many partners. Len will often invite the fire department to come with him. So on many inspections, you'll see a few people, including the fire chief or someone from the fire department. And particularly if there's been a release, often we'll go out with OSHA or sometime shortly before or after OSHA. I'm going to give you an example of one of our cases. This is a dairy up in Vermont, way up in northern Vermont, and they made cheese. They still make cheese. Years ago, Len learned about this facility, and he learned about a release of ammonia there that could have killed 3 workers. What they were doing is they were taking the oil out of one of the compressors, and the machine did not have a quick closing valve or a deadman valve, and Len talked about the importance of those valves earlier. And so what happened is the workers got sprayed with a mixture of oil and ammonia, and fortunately, they were wearing heavy winter clothing. It was deep in winter in Vermont, and that clothing protected them somewhat from the release. The workers were protected, but not so the cheese. The company lost about $1 million worth of product, which it could ill afford, as it was a small company. And the release went on for a very long time because there was no emergency shutoff button to help the responders turn off the machines or turn on ventilation. There was no ventilation. And so the emergency responders couldn't get in there for a long time. We inspected the facility with EPA's emergency responders and found that it was, the ammonia refrigeration system was quite decrepit and corroded. Over on the right, that picture you see on the right is two ammonia pipes that are so corroded that the metal is starting to join together from the 2 pipes. Other problems included icing on pipes and vessels, no maintenance inspections, no operating procedures, and no training. This was one of those very scary facilities where we felt like we needed expert help. So we brought in an expert to do a second inspection and help us determine how we were going to handle the facility. What we were trying to do is balance the need to have the system fixed, which we thought might involve the removal of some ammonia, with a desire not to shut the plant down for too long, because we were worried about jobs and the company's viability. Ultimately, we issued a compliance order. The facility removed the ammonia and installed a new refrigeration system right next to the old one. We followed this order up with a penalty action, working with the company to make sure that the combined effect of the compliance expenditures and the penalty wasn't more than the company could afford. But this all took a long time. It was very complex, very hard on both the company and on EPA's resources. And this is just one of many such facilities that we've dealt with. Given experiences like this, we have thought long and hard about whether there's a more efficient and proactive way of trying to improve compliance at particularly the smaller facilities, those with less than 10,000 pounds of ammonia. And what we've recently gotten is approval to try out a pilot project here in New England. We have national approval for this pilot, but for now we're just going to pilot in New England to see how it works, to address a core problem that we're seeing at a lot of these facilities, and that is the failure to even understand what the hazards are, the failure to do a hazard review or a hazard analysis that uncovers some of the deep safety hazards at the facilities. So the idea behind this pilot project would be to, without requiring Len to go visit all these facilities, to focus in on the first clause, the first duty of the general duty clause, to have facilities identify hazards which could result from releases using appropriate hazard assessment techniques. Essentially what's going to happen is we are identifying the universe of facilities in New England with under 10,000 pounds of ammonia. And for purposes of this pilot, we're focusing on those that have between 1,000 and 10,000 pounds. So ice rinks out there, those of you with under 1,000 pounds, which I think is most of you, this pilot is not for you. That doesn't mean you don't have to comply with the general duty clause. It's just that we have to be efficient about the use of our resources. We're focusing on those between 1,000 and 10,000 pounds. So we're identifying all those facilities. That's been quite an ordeal. And then in a few months, once the International Institute for Ammonia Refrigeration publishes its new Ammonia Refrigeration manual, which will include some updated industry checklists for doing hazard reviews, we are going to send out a public notice that will explain the initiative, and then waiting a few more months after that, then we'll issue information requests in small batches to determine if companies have identified the hazards at their facilities. If they haven't, EPA will be offering a $5,000 settlement, which is way less than discount. Non-compliance with discount would normally result in, and there'll be some additional requirements. They'll have to conduct a hazard review with the help of a third-party expert. They'll have to meet with responders, and they'll also just have to send us a short statement about what safety measures they are planning to put into place as a result of their hazard review. Don't be scared about the information request if you get one. It's very short, fill-in-the-blank questions, just asking whether you have a refrigeration system that uses anhydrous ammonia, what the inventory is, and whether you've conducted a process hazard review, and finally, whether you've had a significant release in the last 5 years. I'm going to turn it over to Len now to talk about what it's like to go through an inspection, and then some common citations he sees.
So some of you probably on the line I've met over the last few years. Some of you, hopefully, you'll never meet me in the next few years. And the reason is we don't have to give notification of our inspections. Some facilities we do because of how big they are, but if it's because of an accident or event in the news media or death or injuries, we'll be showing up within a day or two, just like OSHA shows up within a few hours. So what happens during an inspection? Well, it's going to take most of your day. I'm just being truthful about it. And for some facilities, it could be 2 days at your facility. So we'll arrive, and it's usually more than just myself. Many times I'll have contractors and other state, federal, and local officials with us. We'll do an opening conference. We'll sit down in a conference room, go over the paperwork, why we're there. And just so you know, Emergency Planning Community Right to Know Act requires a notice of inspection that we have to give to you. We'll explain what we'd like to do. We'll ask for some documents, and then we'll go for a walk through the entire facility. And when I say walkthrough, I mean outside the facility and inside the facility. And if you're an anhydrous ammonia facility, many times we end up on your roof at some point during the inspection. Then what happens during this walkthrough, we tell people right up front, we're going to say things you may disagree, and that's fine, but we're going to point out issues and things that you may want to be looking into after we're done. Then we'll come back, we'll ask for a few minutes, because we've put our thoughts together, and recap the main issues that we think that you should be looking into after the walkthrough, and what other additional documents we may want to be requesting from you. We'll put that together. Then we have what we call the closing conference, where we go over what we think are some of the major issues to look at and the request for documents. And then time for you to have any questions. That's the inspection part. Then will come reports and notifications and back and forth. So, as I said, how do you get on our list? Well, if you're on, if you have over 10,000 pounds of anhydrous ammonia, you're on our RMP list, and we have to inspect so many of those facilities a year. But then for facilities that are not on the RMP list, less than 10,000, you have an accident. And it could be a death to injuries, public complaints of odors. It's amazing how many odor complaints we get from ammonia facilities, or just an event that you impacted, such as draining your ammonia into the sewer system of the city or into the marsh out in back of your facility. So those type of events will lead us to come to your facility. I'm going to go into some of the common citations or things that we see at a facility, and they're not in any particular order. So the first one is not the number one, necessarily the number one issue, but inadequate maintenance. It is a major component, from simply keeping rust off of facilities, the insulation intact, changing out valves, the either half year or the monthly testing of the ammonia detectors, or getting them calibrated annually or biannually. I mean, maintenance is a heavy key factor. Another one is lack of training. You know, if you expect people to work on a system and not rely on a contractor, then what training have you sent them to? What training do they have on that piece of equipment or those procedures? And how do you make sure that they've been trained? Another is the HAZS analysis, or process HAZS analysis. It means that you're identifying issues and how you're going to correct them or fix them, or improve upon them. And what happens is, a lot of times we see people have done these process HAZS analysis, or they have third parties come in and do audits for them. Sometimes your insurance companies do them, and then no one does anything about the recommendations. That is critical, that you have to do something with those recommendations, no matter who they're coming from. Standard operating procedures. There are some slight differences between RMP and PSM, but just having written procedures for people to follow. Lack of impact protection. That means, you know, pipes in tanks. Do you keep them from being bumped and so forth. Missing quick closing valves on oil pots or any type of equipment that may require that. The biggest one is labeling. The labeling is not just for you. It is for your contractors. It is for emergency responders. If you want them to go shut a valve off and you tell them that it's on the high pressure side of the liquid system, they should be able to follow that piping with those signs and then get to the valve that's properly tagged and identified so that they can shut it off. And just as you do for work with your contractors, for isolation, lockout, tag out, it's the same thing. Lacking these tags is really critical. Not having alarms or detectors in the proper places, both inside the ammonia machinery rooms and outside the ammonia machinery rooms and outside the building, so that when responders come, if someone dials 911, they know it's not a fire, it's an ammonia leak. And how they behave will be vastly different, and how they treat the victim, if there are any. Doors, it sounds simple, tight-fitting doors. A simple thing, but it's amazing how many doors are not tight-fitting to keep that ammonia in that room. So when the ventilation system goes on, it works properly. No panic hardware on the doors. I would not want to be in a dark room with ammonia gases where I can't see and I'm tearing up and trying to get out, fumbling for a handle, not knowing if it's a round handle or a straight handle. That's what panic hardware is for. I can crash into the door or whatever it is, and it will open and I will be able to escape. Again, no emergency plans being posted outside in the critical spots outside the ammonia machinery rooms with the P&IDs posted. So those are some of the major elements that we have seen in New England, and you can get into a lot more than that, but those are constantly almost in every one of our cases that when we looked back over. Recently, like we said, there are facilities in which I've done and Catherine's talked about. People get hurt, people die, and I just don't like doing those type of inspections, especially when you have to go and look at what someone was wearing or go to the morgue to collect information and evidence. Recently in Boston, there was a death of a worker at a facility, and they passed away in the ammonia machinery room, and the EPA just recently settled with the corporation for $700,000. And OSHA had already settled with them as well, and some other state agencies on other issues regarding this event. So hopefully I'm not there because of injuries or deaths or an environmental impact. And if you take some of the issues that we've pointed out and some of the key safety elements that have been identified by the EPA, hopefully you'll have a safer facility.
Great. Thank you, Len, and thank you, Catherine, as well. We will be taking questions that Len and Catherine will both be here to answer. But before we do that, I want to take a minute to let you all know about some additional resources, EPA and otherwise, that are available to you. So you already heard about the key safety measures document that Len was talking about earlier. That is available on the EPA website. And for those of you who are ice rinks on this presentation today, keep an eye out, and if you aren't on Janet Bowen's ice rink email list, send us an email and we will put you on that email list so you can hear about workshops, tabletop sessions, other materials that are coming down the pipeline. We have at least one fact sheet for ice rinks with ammonia refrigeration systems planned to be launched in the next, I'd say, month or so. So keep an eye out for some of those resources. Now, I'm going to go through these slides a bit quickly so we can get to your questions. But again, these slides are all available to you in the handouts or resources tab on your screen, and we'll also send you this presentation after the webinar, so you can access that information that way. So the Compliance Assistance Tools and Resources document, this is available to you on the EPA website at the link on the screen. This list of resources includes helpful links to information from us at EPA and also industry standards and resources from trade associations and other partners in ammonia refrigeration. So each of these items has not only a link to the resource, but a detailed description of the resource to help you find what it is you're looking for. Now, this is the EPA Accident Prevention and Response Manual. The 4th edition is on the EPA website. This manual summarizes requirements of environmental and safety laws for anhydrous ammonia refrigeration system operators. And there's a list of relevant federal laws and regulations in Appendix C of this manual. Now, Cameo Chemicals, this is actually a NOAA website resource. It will help you find response information and hazard information for thousands of hazardous materials, including ammonia. So that's health hazards, cleanup procedures, different gear you need to have if you're handling a toxic chemical, other chemical properties. And there is information about regulations available on every single chemical page. That's not just EPA regulations, that's also regulations from OSHA and Homeland Security. So you can have all that information available to you in one convenient location. Now, the Emergency Planning and Community Right to Know Act, Tier 2 reporting. That's something we didn't go into too much detail on today, but it is worth pointing out that for facilities with 500 pounds or more of ammonia or certain amounts of other substances on site,
they need to submit EPA Tier 2 reports to the State Emergency Response Commission, the local emergency planning committee, and fire department by March 1st each year, or earlier if you bring a new substance on site for the first time. You need to report that much sooner from the date that you bring it on site.
Now, different states may have different reporting requirements or processes, and those requirements actually may not apply to a municipally owned and operated ice rink if you're in a state that does not have an OSHA-approved state plan to protect workers. So, bottom line, you should check your state website for details. The link below will link you to the requirements and procedures for your individual state. There's also a link here for the Tier 2 Submit software, which many states use for helping facilities to submit their Tier 2 reports electronically. Now, this next resource may be especially useful to you if you're a facility that has not been submitting EPA Tier 2 reports as of late. This online portal launched in 2015 to help entities to disclose certain violations and submit a certification of their compliance with certain regulations and get a penalty reduction. So there are certain caveats to this. Timeframes matter, what the requirements of your facility are matters, but it is something worth checking out if you're having some questions about what you need to be doing. So you can learn more about this policy and this resource at the links on the screen. So finally, accidental releases. If you have an accidental release at your facility, there are some phone numbers you need to know and need to call right away. First, the National Response Center, whose number is up on the screen, your state emergency response number, and we've provided the number for all New England states. If you're calling in to this webinar from outside New England, you can find your state phone number online. And then, of course, 911, your local contact. All three of these calls are required under federal law. For ammonia, the federal reporting threshold is 100 pounds. If you have a release of 100 pounds or more, you do need to call all three of these numbers right away. That number may vary for certain states, and there may be different requirements for different states and local groups. So please check in with your state and local contacts to make sure you know what the requirements are in your area. Okay, finally, here are some more federal contacts you might want to have in your back pocket if you have further questions. There's the Department of Homeland Security up here. We also have some contacts for you from OSHA and the Department of Labor. Len Wallace, who you heard from today, is your EPA Region 1 contact. You have questions about compliance or inspections. Also, Janet Bowen, who I work with in the Assistance Office and is here on the call today. She manages all the contact lists, so if you want to be informed of any resources that are becoming available or be getting regular updates on information about workshops, she is the person you want to contact so that you can be added to her email list. So now, without further ado, I think we're ready to hear some questions.
Excellent. Thank you so much, Elise. I'm Janet Bowen. I work with Elise in the assistance group, and I've been tracking your questions, so please still type in some questions if you have them. We did try to leave a lot of time at the end of the webinar for folks to get questions answered. If we don't have time to get to your question, or it's a more complicated question, we may follow up with you directly after the webinar to give you specific guidance. So I have a couple questions related to releases. One is, what counts as a significant release, or how is that defined under the General Duty Clause pilot?
I'll take that one. So under the General Duty Clause pilot, one of the questions in our information request is whether you've had a significant release in the last 5 years. And the specific wording of that question is, has the facility experienced an ammonia release in the last 5 years that resulted in deaths, injuries, significant property or environmental damage, evacuations, or sheltering in place? So we're not looking at, you know, teeny little internal releases, but at the major ones. And that's because we can't, such facilities will not be eligible for the pilot.
Great, thank you. Another question related to releases. How do you know how much is released in an incident?
This is really important. All the state, federal, and local laws say you have to immediately notify of an event. You many times do not know actually how much ammonia is released during an event, especially in ammonia systems. You will never be in trouble for making the 3 calls, and in some cases, some states require additional calls. You will never be in trouble for making the notifications. Failure to make notifications once you're aware of the event, and you take several days and you find out you're above the RQ, which is 100 pounds for the federal, you are in trouble. So it is very difficult for ammonia facilities to figure out how much is actually being released, because many times you don't know what valve it was initially. You won't know if it's a compressor, it's a gasket. What we tell folks is, make the 3 phone calls or more, and you will never be in trouble. So you should never be worrying about what the RQ is. You should be worrying about making the notifications to the folks that can help you, along with your contractors that will come and help you repair the system and get it back up and running.
Thank you, Len. Another question has to do with MSDS sheets or SDS sheets. Is there a standard SDS sheet for anhydrous ammonia, or does it vary by application or location?
SDSs, as you know, with global harmonization, were actually standardized by OSHA almost 4 years ago. What changes is you have to have the SDS from who your supplier is. Who did you buy the ammonia from? If you don't know who you bought your ammonia from, OSHA requires that you produce an SDS. So they're all standardized by how they're laid out. However, the information can vary slightly from manufacturer to manufacturer, or supplier as to the quality and breadth of the information in the SDS. So they're standardized, except what the manufacturers put into them.
Great, thank you, Len. Another question is, are dead man valves a requirement on the oil pots? Are you required to have a dead man valve?
Yes, that's one of the industry standards that applies, and EPA conferred with the International Institute for Ammonia Refrigeration. That's definitely one of those items that both the industry and the EPA agree should be in place at all facilities, no matter how much ammonia you have, and no matter what the age of your facility is.
Great, thank you very much. This is a question related to risk management plans, facilities. What if a facility has 2 engine rooms under 10,000 pounds? Are they subject to RMP, or is it a general duty facility?
What Let me try.
Sure.
All right, and then you can jump in.
Yeah.
We may split this one. That's not an easy question to answer. And the reason is because the RMP rule also takes into account, can the two systems interact with each other and affect each other? So just because the two rooms may be separate and each below 10,000 pounds, it may or may not be an RMP facility based on some of the other criteria that you have to look at in this case.
Yeah, we might look to see if any part of the system is shared, for example. But again, as I mentioned earlier, it's entirely possible that if you have two ammonia systems and they're completely separated, maybe they're in completely different parts of the building, one could be over 10,000 pounds, one could be under 10,000 pounds, and you'd be subject to the risk management program at one and the general duty clause at the other. But often, if you have two refrigeration systems, there'll be some sort of equipment that's in common, and then we would consider all of the pounds for both in coming up with what the RMP threshold amount is at that facility.
We are getting some general questions about the status of the RMP updates, specifically the recent court decision regarding 68.80, 68.93, and 68.96. So I don't know if Kathy wants to take that.
Okay. The first thing I'm going to do is just tell you to do a web search to find this document that's RMP, called RMP Amendments Compliance Information, and Janet has a link to that as well. What's happened is that there's been a lot of pulling back of some new regulatory requirements, reproposing of others. There are some emergency response coordination requirements that are newly applicable, and I would, if you annually coordinate with your emergency responder, keep them up to date with all of the contact information and your emergency action plans or emergency response plans, and try to meet with your responders. That's the most important thing for right now. But go to EPA's website, to the documents that Janet will send you for a description of what new requirements are in effect now.
Great.
If everybody checks their checkbox, I actually sent the link out. So if you just click on it, it will direct you to the website.
Great. I have another question about completing process hazard analysis and whether you have to actually submit them to someone.
No. If we're talking about the RMP regulations, you have to have that at your facility available for inspection when or one of the other inspectors arrives. And that process hazard review or analysis has to be updated every 5 years. What has to be submitted to EPA is the risk management plan. And that's essentially just a summary of your whole risk management planning program. It's just a very short summary. But the bulk of your RMP program will be kept at your facility. What else do you want to say, Lynn?
You may want to comment on the GDC pilot program.
Right. And then under our general duty clause pilot program, the process hazard review that we expect you to have in place to comply with the general duty clause, that too needs to be kept at your facility. And we will not be requiring you to submit that as part of our pilot.
So I have a follow-up question on the general duty clause pilot. If when they get a letter, they have done those things and put them in place by the time they get the letter, would there be enforcement action against them?
No.
Excellent. I'm sure people are excited about that. So if you know what the questions are, go out and make sure that you have those in place before you get a letter from EPA. I also got some general questions about people that are maybe just coming into the RMP program or OSHA program and may not have all the requirements fully in place. What's the best mechanism for them to make sure that they're in compliance in time?
Well, one of the things is if they're in RMP, which this seems to be, there are key elements and key deadlines. So just coming into RMP means they had to have a PHA done, pre-startup done if they're a brand new facility critical coming online. Also within that coming online, their SOPs and their maintenance schedules should have been pre-planned. If they're upgrading their facility, it's still critical that all those things be put in place before they did, but if they found out through their PHA they weren't quite, that's why the PHA, the hazard analysis, gives them and ranks the severity of those things that need to be fixed, and you should be on a time schedule, and most of that should be done within a year or less. And if it's going to go beyond a year or more, you have to really document why it's going to take so long. And sometimes it's capital outlay and money for major fixes, but you still have to identify it and track it.
Excellent, thank you. Another question has to also do with RMP. How often should the RMP be resubmitted to EPA?
The short answer is at least once every 5 years, and there's some other requirements for when it has to be more frequent than that, but typically it's once every 5 years.
Great. So if folks on the line have additional questions, feel free to be typing those in. I don't have any additional questions at this point. Does anybody have any closing remarks that they want to leave facilities with before we wrap it up? And a reminder that folks that are on the line, please complete the short survey. I will be mailing out a copy of the presentation, some of the links we talked about today, and probably a summary of the evaluation so that you can get an idea of what other folks said about the webinar. But it's really important for us to get feedback on this event, understand how much you may have learned from the event so that we can offer more of these in the future. So please do that.
I just want to remind folks, me and Jen are available for technical assistance. We're going to be doing lots of workshops and other events in the future. Also, the folks, Charles Colley from Homeland Security, Gabe Porter, and Mark Heffron from OSHA are critical resources to ask about their programs, and they will direct you to other folks who can help you. So we're here to assist. We would rather have safe facilities and no more accidents at our facilities here in New England. So please feel free to contact us at any time.
Great. Any closing remarks from you, Catherine?
As an enforcement person, I just want to thank you so much for joining the webinar today to try to get ahead on compliance. We really would love to see the fruits of this labor when Len goes out on his next inspection.
And I'll say one more closing remark for the ice rinks, because we've had a specific focus on ice rinks in our region. I do have a list of all the ice rinks, at least I tried to identify them, and we are developing an ice rink ammonia specific fact sheet, since a lot of ice rinks won't be part of our pilot. It's specific to ammonia refrigeration at ice rinks. We're also going to hopefully work on some additional ones for EPA Tier 2 reporting and other events for ice rinks. So we will be doing some specific work with you, since a lot of them will fall outside the pilot. So definitely email me if you want to make sure that I send you any ice rink compliance assistance materials.
You know, Janet, it's not only ice rinks, but curling facilities.
That's
here.
right, curling facilities. You can't forget them. That's right.
Should have an ice rink and curling facility on that poll. Yeah. They're all important to us. Great. Thank you, everyone, for joining us today. We'll be sending out an email shortly with some slides and some other follow-up materials. And thank you for taking the survey and for being with us today.